energy stored in a capacitor. We know that capacitor is a device which stores charges in it. At the same time, it stores energy in it. Now let us try to obtain an expression for the energy stored in a capacitor. For that, I am considering a parallel plate capacitor of capacitance C is equal to epsilon 0 A by D. If a charge small q is given to the capacitor, then the potential difference across the capacitor is V, and the capacitance is given by C is equal to Q divided by V, or the potential difference V is equal to Q divided by C. Now I am going to add some more charge into that capacitor. I am going to add a very small quantity of charge dq to that capacitor. For that, I have to do some work against the existing electrostatic force. So the small amount of work done to charge this capacitor by an amount dq is given by dw is equal to V into dq. But we know that V is Q by C. Therefore, the work done is equal to Q by C into dq. Now I am going to calculate the total work done in charging the capacitor from Q is equal to 0 state to Q is equal to capital Q. I can do this by integrating the expression for the small work done dW to give a charge dQ within the limit 0 to capital Q. Therefore, the work done W is equal to integral 0 to capital Q, Q by Z dQ. We can perform this integration by using the formula integral x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Here we have the power of q as 1. So it is 1 by c into integral q dq, that's equal to q square by 2, and we have to apply the limit from 0 to q. When you apply the result limits, the equation for work done is 1 by z into q square divided by 2. Or it can be written as the 1 by 2 into q square by c. So this much work done by the agent in charging the capacitor is stored in the capacitor as its energy. Therefore, this work done is equal to energy of that capacitor. Therefore, energy of that capacitor is U is equal to half q square by c. I can express this idea in another way in terms of C and V. So we can make a substitution for Q where Q is equal to C into V. So when that value is substituted here, the equation for the energy will be U is equal to half into C square into V square divided by V, and that is equal to half CV square. Similarly, we can obtain another expression in terms of Q and V. Now, what is meant by energy density of a capacitor? The energy stored per unit volume of a capacitor is called its energy density. So, we can find the energy density by dividing the total energy stored in a capacitor with its volume. That is, we can divide half CV square with A into D. This is the energy density. So, we can make some modifications. We know that the potential difference V is equal to E into D and C is equal to epsilon 0 A by D. Make these substitutions. Energy will be equal to half CV square. That's equal to half into epsilon 0 into A by D into ED the whole square. On simplification, this equation reduces to half into epsilon 0 into E square into A multiplied by D. So dividing this with the volume of the capacitor, we will get the energy per unit volume or the energy density. So the energy density is equal to U divided by A into D. And when this term is divided with AD, we will get a result as half epsilon 0 E square. And that is called the energy density of the parallel plate capacitor.